Okay, so taking this a little further then, let's see what the position time graph of this will look like. And then we're going to also see how that position time graph makes exact sense with what we know about the velocity of this object. So here I have a position time graph for this rocket car. And these are seconds down here, 1, 3, 5, 7. These are meters here. And so after the first second of time, it had traveled 2.5 meters. After the second 7.5 meters. After the third second, it had traveled, whoops, go back. After the second, it had gone a total of 10.5. And then after the third second, it had gone a total of 23. And then after the fourth second, a total of 37. And after the fifth second, a total of 45. And after the sixth second, a total of 47.5. And then after the sixth second, back to 45. The seventh second and eighth second, back to 37.5. So that's what the position time graph looks like. Let's do a best fit curve through this. All right. I'll give that one more shot. There we go. All right, so what do we see about this? Well, we notice that early on, the slope here is not very much, but a little bit later on, the slope is greater. Well, that makes sense because early on, the velocity is very low, and later on, the velocity is much higher. Now, right in here, the slope starts to go back again. All right, well, that's the velocity getting lower. Right here, the slope is 0. That corresponds with the velocity being 0. And then again, the slope gets greater as the velocity gets greater numerically and in the opposite direction. In other words, it's speeding up here and slowing down and then speeding up, but in the negative direction. Now, we can also make a velocity time graph for this. So let's go ahead and make a velocity time graph. This is going to be velocity in meters per second. And this is going to be, let's try that again. This is going to be velocity in meters per second. And this is going to be time in seconds. 3, 4, 5, 6, 7, 8. And 5, 10, 15, -5, -10, -15. Okay, so now we can go ahead and plot a graph for this. So the velocity started out at time 0 at 0, and then at 1 second it was 5 meters per second, 2 and 3 like that. And then at that time, then by the 4th second we had begun to slow down again. Okay, so it started to slow down again. And then velocity went negative. So our velocity time graph looks like this, and then like this. Okay. Now, as messy as that is, I hope you can see that this is a straight line segment and this is a straight line segment. And actually, those straight line segments tell us something because the slope of these graphs equals the acceleration. And so you'll notice there is a constant acceleration here of +5 and a constant acceleration here of -5. And so from each of these graphs you can translate back to the original graph. So for example, again, from the velocity you can get the acceleration. In fact, let's go really crazy here. Let's make an acceleration time graph. There's acceleration time. I'm not going to put numbers on here, but +5 like that, and then -5 after that. All right, so there's the acceleration time graph. And we can transport from here to here and back by thinking about slope, and here to here, thinking about slope. The slope of this gives us this. The slope of this graph gives us this.